Okay, so as we just said, I'm going to repeat for the recording. Quiet down, please. And the limit as x approaches positive infinity, we get 2 times infinity times e to the infinity, which is 2 times infinity, which is infinity, right? So that one, it's pretty straightforward. You plug in a bunch of infinities and multiply them together, you're going to get a really big infinity. All right, the negative infinity is a little bit trickier. So if we do the limit, now I got to lift this thing up. Oh, I can't. You know what? Forget it. Let's just keep it there. All right. So if we do the limit as x approaches negative infinity of 2x e to the 2x, when I plug in the negative infinity, so I get 2 times negative infinity times e to the negative 2 times infinity. So, or e to the 2 times negative infinity. So when we have e to a negative exponent, when you have anything to a negative exponent, what does that mean? It means it goes down to the bottom, right? So we can't write that this equals this because you can't equal infinity, but I'm just going to over here, down here, write separately. So 2 times negative infinity over, so this would be e to the 2 times negative infinity, which is the same thing as over e to the positive 2 times infinity. So a negative exponent up top equals a positive exponent on the bottom, right? So now you have to decide, is this going to infinity or is this going to 0? We have 2 times infinity on top. We have an infinity on the bottom. When you have an infinity over an infinity, does it equal 1? Does it equal infinity? Does it equal 0? So you have to think about it. Well, without, again, I'm not writing that the limit equals this. I'm just going to pose this to you. Oops, I'm not writing the 2. 2's on top. Okay. 2x over e to the 2x. So if we were to do this limit as x approaches infinity, remember yesterday we touched on this thing called comparative growth rates. So we talked about which types of functions grow faster. What kind of a function is y equals 2x? What kind of a function is that? It's a polynomial, right? What kind of a function is e to the 2x? That's an exponential. When we have a polynomial over an exponential and we do the limit as x approaches infinity, this whole thing is going to go to 0, right? So in this case, this limit as x approaches negative infinity, since it takes the e and kind of pops it down to the bottom, you end up with essentially an infinity that's growing slow over an infinity that's going really fast, and the whole thing ends up going to 0. Kind of tricky, little bit pushing you out of your comfort zone. So maybe a little bit more than what you would see on your test. And just so you know, there's a shortcut way to do this, a method to find the answer without any ambiguity that you will learn in like maybe 3 months, called L'Hopital, which is kind of fun. So anyway, all right, so I pulled up the scoring guidelines for this problem because this was a legit free response question back in 1998. And so they didn't require any work at all. They just answer, because there's really no work to show, right? So the limit as x approaches negative infinity is 0. Limit as x approaches infinity, they accepted either infinity or DNE because technically when the limit's infinity, it doesn't exist, right? So, and it's just point, done. So, all right. So today we are circling back to the first lesson of the unit. So our first lesson of this unit, I don't know if you remember it, it was slopes of secant lines. All we did were slopes of secant lines. Slope, 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 over and over and over. So your whole homework that night was all these funky find the slope problems. Today, then over the next week, we learned how to find all these limits. Today we're putting it together. Today we're going to learn why did we find all those limits, right? All we learned was how to do them. now we're going to say, well, why did we learn all those techniques for finding limits? Because now we're going to use that to find slopes of tangent lines. Woo-woo! Okay, which you think is not a big deal, except if you think about a slope being a rate of change, the slope of a tangent gives you an instantaneous rate of change. It is a big deal. It like opens up this whole world of applications that you can now do that you couldn't do before you knew how to do this. So, all right, so anyway, so here's what we talk about. So this is the first time you'll have ever seen this word. You don't have to write it down today because we're going to get real deep into this on Tuesday and a little bit tomorrow or Monday. But this word derivative. So today what we're doing is actually finding derivatives, but you just won't know it because you'll think that you're just finding limits. Okay. All right, so far we know how to find the slope of a secant connecting points from A to B. And I wrote out what does this mean. So what does slope of the secant mean? Slope of secant, I call SOS, slope of secant, that gives you an average rate of change. An average rate of change. So it's the rate of change from one point to another. An average rate of change. And we calculate it by finding f of b minus f of a over b minus a. Now, this formula is just fancy talk for change in y over change in x, right? So if you're going from a to b on your x, then your change in y's would be f of b minus f of a. And your change in x would be b minus a. I want you, now that you are in calculus, I want you to think of slope no longer as change in y over change in x. I want your brain to start thinking of it as f of b minus f of a over b minus a, because this is the way you're going to see it for all of your math classes to come. Like if you go on to higher math, this is it. So you got to like train your brain to see this and think slope. F of b minus f of a over b minus a just means slope. Okay? All right. Now, this gives you an average rate of change. That's slope of the secant. That's what we've been doing. Today, we're going to take it up to slope of the tangent, and I found a GeoGebra. Since your book didn't have any really good demos on this. Okay. All right, so we have this graph of this like I can't even say it now, quadratic function, right? And on this quadratic function, we have a point called P, and we have another point called Q. In the back, if you can't see it here, I'll write it bigger. This is P, this is Q. So there's a blue line that goes through P and Q. That blue line is a secant line. It's a line that passes through 2 points, right? It's a secant line on the function, this quadratic function. That blue line has a slope. The slope of the blue line is around 4. Okay, so to go from one point to another on the line, you go up 4 over 1, up 4 over 1, up 4 over 1, right? Okay, so the slope of this line is around 4. We don't want the slope of that line. We want the slope at P. If I want the slope at P, what do? I'm going to take my Q, this point right here, and I'm going to move it closer and closer to P. So see how my secant line, it's like we're going along the function. As we move until Q is like really close to P, it's like right on top. You can't even tell the difference. That's amazing, right? Okay, so how do we move a point closer, right? You just like take this point and pick it up and move it. That's what limits do, right? So the limits are what push the Q point towards the P point until it's right on top, and then you find the slope of the tangent. Okay, so visually, that's what we're doing. So here's what we're doing analytically. I gotta see if I can move this thing up. Go up. There we go. All right, that's fine. That's better. Okay, so the slope of the line tangent to the curve at point P is, so now instead of slope of secant, we have slope of tangent. Instead of average rate of change, we have instantaneous rate of change, which I call IROC. Instead of AROC, it's IROC. And what does it equal? It equals this formula right here. Now, notice we don't have a B and an A anymore. That's because we don't have 2 points anymore. We have 1 point. We have one spot where we want the slope. So now our 1 point, which is where x equals a, that's our 1 point. We want the slope at that 1 point. So for the b part, we just keep it in terms of x because the x's are moving. The x's are changing. So now this is our slope, f of b minus f of a over b minus a, except we're going to keep the b as an x. So f of x minus f of a over x minus a. But now we're going to take the limit as x approaches a. So if we do the limit as x gets closer and closer and closer to a, the closer x gets to a, what y value are you getting on this? Meaning what slope value are you approaching? That's the slope of the tangent. All right, and a little note, I put this little note. Note this is the same as the slope of the curve. Once in a while, you'll see a problem where they'll say, what's the slope? So like here it says find an equation of a line tangent to y equals x squared. If they say, hey, what is the slope of y equals x squared when x is -2? Slope of the curve is the same thing as the slope of the line tangent to the curve. So because that's the whole definition of a tangent line, right, is it shares the same slope as the function at the point of tangency. So if you're ever asked for a slope of a function, it's the same thing as slope of a tangent. They give you the same thing. All right, so we're going to use this formula to find the equation of the line tangent to y equals x squared at the point -2, 4. So line tangent. So when we need to write an equation of a line, what 2 things do we need? Yes, all right. Okay, so you got slope and point and slope, right? Because we don't have to have a y-intercept, right? We can find a linear equation without the y-intercept, right? All you need is a point on the line and the slope of the line, right? Okay, point on the line, slope of the line. I'm going to talk in like 2 minutes. I'm going to do a little plug for something else, but it occurred to me now because we're doing linear equations in Calc 3, but it's going to come up again in a minute, so we'll talk about Calc 3 in a minute. All right, so we're going to go ahead and do this. So find the equation of the line tangent to y equals x squared at the point -2, 4. So do we have a point?
Yeah.
What's the point? -2, 4. It was given. It's right there, right? There's your point. Okay, so the only thing we need to find is the slope, right? So the slope, which you can call m, I don't care. So the slope is, well, let's see. We need it. What a value? What's our a for this formula? -2. It's the x value of the point, right? So our a is that x value. It's -2. All right, so we have the limit as x approaches -2 of f of x. What is f of x for this problem? It's x squared. It's your function, right? Remember that when you write y is synonymous with f of x, right? Y is just written with output variable notation. This is written in function notation, but they mean the same thing, right? So when you see y equals x squared, you could think of that as f of x equals x squared. So the first part of your formula says, hey, f of x. So what is f of x? It's x squared. Next, you want f of -2. Well, f of -2 is -2 squared, right? Or 4. So I'm going to write -2 squared, but you can write 4. Over x minus -2. Wow, it's like limits we've done before. Right? Especially if you change that to a 4, then it should look really familiar with what to do. So it's a good thing we learned some limit techniques, right? Okay, take a minute, find the limit, and then see if you can write the equation of the tangent line. Tyler, I'm going to just rewrite this before I put you on the spot here. You know, just to clean it up, right?
Yeah.
Tyler, what is your personal favorite F word? Is it?
Yeah.
For real?
Yeah.
All right, we have it recorded that that's your favorite F word. All right, good. It's mine too. So if your favorite F word is factor, we should do it, right? Okay, so when you factor the top, what do you get?
X plus 2.
Good, lovely difference of squares. Tyler, what can you do then?
Cancel.
You cancel the x plus 2's. So now, negative 4, right? What does that negative 4, what does that represent?
The tangent.
This is the tangent line, it's negative 4? You're close.
Slope.
The slope of the tangent line, right? Okay, do you all understand that? This is not the tangent line itself, it's the slope of the tangent line, right? So we're not done. We still have to write the equation. So lucky for us, we know a point, we know the slope. What would be a good form to use? Point slope form, right? Oh, sorry, I didn't mean to talk over you, Tyler.
No, yeah.
Okay, all right. So point slope form, so which I think is what you were about to say, y minus the y value of the point, right, equals the slope times x minus the x value. Since it's x minus negative 2, you can just write x plus 2. And then you're done. You stop. Walk away, right? Pencil down, you're done. If you simplify, that's on you. Because if you simplify wrong, I have to take off. But if you just stop here, you get full credit. So let's just stop here. Okay? Okay. All right, let's try another one. So, fun with fractions. Fun with fractions, right? That's our second favorite F word. Okay, so fractions. All right, find the equation of the line tangent to f of x equals 2 over x minus 5 at x equals negative 2. Same a value. We're still looking at an a of negative 2. Notice I didn't give you the y value associated. You're going to have to figure it out yourself. So see if you can find the slope, right? Limit as x approaches negative 2 of f of x minus f of negative 2 over x minus negative 2. This is going to be so much fun. I am going to, so we need, what two things do we need to write an equation of a line?
Point and slope.
Point and slope. Point and slope. Right? So we're going to find, I'm going to find the slope. Whoa. Ugh. Every time I start back up, it moves the thing. All right. Slope. So we have the limit as x approaches, what's our a? Negative 2 of f of x, which is the function, minus f of negative 2. So I got to plug a negative 2 in. You get negative 2/7. So is it okay if I write this as plus 2/7? So you all, is that minus negative? Okay. Over x minus negative 2, which I'm going to write as x plus 2. All right. How do we deal with a complex fraction? And if you don't like this method, it is so fine if you want to go ahead and just combine like you've always done, right? I like this method, it just saves me a little time. But if you don't like it, that's absolutely fine. So I'm going to multiply the whole top and the whole bottom by the LCD. When I do that, first I'm rewriting my limit statement. Okay. 2 over x minus 5 times 7 times x minus 5. The x minus 5's cancel, and I'm left with 2 times 7, which is 14. Here, 2/7 times 7 times x minus 5, the 7's cancel, And I'm left with 2 times x minus 5. Should I multiply out the bottom?
No.
Never, ever, ever. All you will do is make your life complicated, all right? So we keep the bottom separate. I don't care how you write it as long as it's mathematically correct. Okay. Here's my question of the day. Let's see how good you are at algebra. Let's see. Pranav, how are you? Good. Do these x minus 5s cancel? No? Are you sure? It would make life so much easier if they cancel. Do they cancel? No, they don't. They don't. Now, the reason they don't cancel, do you want to tell me why they don't cancel?
Because there's addition on top.
Yes! That's beautiful. Do you guys hear that?
Yeah.
They're not in every term, right? They got to be in every single term to cancel. And since you've got addition here, you better see an x minus 5 in every single term, right? Or you don't get to cancel it. It's so tempting. Don't fall for it, all right? It's a trap. Speaking of Star Wars. Okay, so instead, we just need to multiply out and combine like terms on top, right? So we have 2x, and then we have plus 14 minus 10. 2 times 5 is 10. So 14 minus 10, so you end up with plus 4. Okay. Lucas.
Yeah.
How are you?
Good.
Yeah? Happy Friday.
Happy Friday.
All right. There's nothing cancels. What do I do?
You factor out the 2.
Factor out a 2 on top. All right, and now does something cancel?
Yes, that's
The x plus 2's. Goodbye. As soon as you cancel, that means plug in, right? Once you cancel, that means the 0 over 0 is gone, and now you're ready to plug in the number. So we plug in the number. When I plug a negative 2 into the number 2, what do I get? 2. There's no x there, right? It's just 2. All right. On the bottom, I get 7 times negative 2 minus 5, right? So 7 times negative 7, so negative 49. So my slope is negative 2 over 49. Am I done? Is that my equation, my tangent line?
No.
No, I still have to write the line, right? What 2 things do I need?
Point and
Point.
slope.
Point and slope. There's my slope. They didn't give me a point. I'm done for. That's it. Not enough information, right?
No.
No.
All right. How do I find the y value, Keegan?
Oh, you plug in negative 2.
Plug the negative 2 into the function, which you already did, right? It's negative 2 sevenths. So our point is negative 2 sevenths. So our equation is y plus 2 sevenths, because minus negative 2 sevenths, equals negative 2 49ths times x plus 2. And aren't we glad we don't have to simplify? We're done, right? Okay. So how did we do with the fractions? Give me like a thumbs kind of a thing. Let's see. Oh, I got a double thumbs. I got a middle thumb. I got a lot of thumbs up and some kind of, by these, does that mean you really could mathematically do it, you just don't like it? Or does that, okay, all right. Well, what that means then is we need to do more, right? So that you feel like this goes to this. Okay. All right, but right now we got to move on. So we're going to learn an alternate definition. This might look a little bit familiar. It's shown up in your homework. And this actually gives you the exact same thing as what we've been doing so far. So take a moment and write down, this is also slope of the tangent. So slope of the tangent, or I rock, same thing. It's just a different formula. that is such a good question. Okay, and I'm going to answer it, all right? In just a moment, I just want to give everyone a moment to just, all you're doing is writing down the formula. Don't write all the words. Just write the formula. Everyone have it? We got it? Okay. So I want to back up. Here we go. I'm going to pull up my GeoGebra again. All right. So we're back to the same picture that we started with. And this was point P and this was point Q. So instead of calling it P and Q, I'm going to let this be X right here. And I'm going to separate X and my other point by a distance called H. Now some texts, and actually most college courses don't use H, they use what's called delta X, which means change in X, right? So the reason that we call it delta X actually seems more intuitive, like it's the change in X, right? So, but H is easier to write and it's easier to manipulate. If you've got X's and delta X's flying all over the place, it's easy to get them mixed up. H is easier, plus when we get into integrals, H, the reason it's called H is because it stands for height. The H stands for the word height. Now, how can this possibly be a height? It's sideways. It's because when we approximate area using rectangles and trapezoids and all that kind of stuff, the height of the rectangles and the trapezoids that we use will be sideways. So this H represents this height here, which we'll talk about later on. So anyway, but that's what the H stands for. It stands for height. All right, so if this is X and this is H, then this value right here, that's X plus H. Does that make sense? Right? So X plus H. Let's talk Y values now. So the Y value associated with this X value is f of X. The Y value associated with this X value would be f of X plus H, right? So if we were just doing old-fashioned slope, change in Y over change in X, change in Y would be f of X plus H minus f of X. Your change in X would be X plus H minus X. But X plus H minus X is just H. So old-fashioned slope would be f of X plus H minus f of X over H, where H represents the distance on the x-axis between the 2 points you're finding the slope of. As we move them closer and closer together, instead of saying, hey, bring X to A, what we're actually saying when we move these closer together, woo, 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 right, like that, is we're saying, hey, let's let our H approach 0. If the H approaches 0, then there's no distance between the points, right? So it's essentially doing the same thing, just with different notation. All right, so, okay, we're going to redo the very first example we did, but now we're going to use this formula. I'm going to help you set this up because it's really important that you do something correctly here, or you're going to mess these all up. You're going to find every single slope is going to be 1. So if you do this wrong, if you get a 1 every single, no matter what function, what point, if you always get 1, then you're making a certain mistake that a lot of students make. So just know, you're in good company, but we don't want to do that. So our slope. So first part is the limit as H approaches 0. Here's the part that people mess up. So f of A plus H. What's our A? -2, right? So we want f of -2 plus H. Now we know f of -2, if we plug in -2 into our function, f of -2 is what? 4, right? So very common for students to say f of negative 2 plus h, oh, well, that's just 4 plus h, right? Done. That's so easy, right? Why do people make this so hard? So, is this true?
No.
No. This is actually f of negative 2 plus h. That would be 4 plus h, right? You're taking f of negative 2 and then adding h to it. We don't want that. We want to actually substitute the whole quantity, negative 2 plus h, in for the x in our function. So f of negative 2 plus h is negative 2 plus h squared, right? You're taking the whole quantity, everything in that parentheses, and that's what you replace your x with. Do you guys understand the difference? Okay. All right. All that being said, so I'm going to write it out. So you have negative 2 plus h squared minus f of negative 2, we already said was 4 over h. Now, even though these problems aren't quite as comfortable to you, usually the math involved in simplifying is actually easier. So take a moment. I'm going to erase all this. I'm going to erase all this. Okay. Just to make it easier. Okay. I'll rewrite. That's your A. All right. Let's see. What's the only thing? Let's see. Megan. Hey, Megan. What's the only thing that we can do? Expand it, right? We're going to distribute that negative 2 plus h squared. So go ahead and take a minute and square this out and combine like terms and see what happens. Luke, what's up? Okay, so this is not a difference of squares. It's not h plus 2, h minus 2. It's h minus 2, the whole thing squared.
Yeah, but it's also if you have -4, so couldn't you just do negative 2 plus h minus
Oh, wow. Okay, you could. Absolutely. Yeah, you could do that. Negative 2 plus h plus 2 times negative 2 plus h minus 2. Yes, that would work. That would work. That's a little bit, if you didn't get, that's okay. Yeah, that's okay. But yes, you could. That's like really good out of the box thinking, right? Okay. Yeah, I would have never thought of that. Yeah, I don't know if that's any easier, honestly, than just spoiling it out.
Especially with like that.
X squared, so it's like he's thinking of X squared,
Okay.
H minus 2.
I'm just gonna FOIL. Yeah. Okay. But factoring is certainly fine. All right. So if you did your math correctly, every single term that doesn't have an H in it should cancel out. If you are left with terms that don't have H's, you've done something wrong. All right. If you do your math correctly, every term without an H, for in this case, it's the 4 and the negative 4, right? They should wash out. Once they wash out, every single term left on top should have an H in it. So now, what can you do? You can cancel an H, right? You can do it from every term. If you want to factor out first and then cancel, that's fine. That's like a nicer, happier way. I'm an old, I don't know, kind of more of a sloppier math writer, and I tend to just cancel. So, but whatever you want. So negative 4 plus H, as long as you land there. So you cancel an H from every term. And finally, you still got to do the limit, right? So what's the limit? Negative 4. So that's our slope. That's our point. So our equation of our tangent line by minus 4 equals negative 4 times x plus 2, which we already found before. Yes, Nisha.
In the example, we have to memorize like the equations.
Yes. Yes, good question. Did you hear that? For your test, you will have to have your slope formulas memorized. Yes.
Are you gonna be like do it in this formula and do it in
Good. Another good question. So, no, I will never tell you how to do a problem. And so if you have one you like better, that's fine. Just go with it. However, what is fair game that I might ask, but you never know.
Come to Student Center East, Nina Rowland.
Okay. What is fair is what I could do is say, hey, which of the following would give you slope of the tangent line? And then you would have to be able to recognize no matter which form I put, right? So we always have a way to make sure you know them, no matter, however, but if it's just like solve this problem, no, I don't care, whichever way you like. All right. On Monday we're doing all applications. Monday is application day, but we're going to start for just a couple minutes with a little application. So the application that you will see in this class more than anything else is motion. And I'm pausing for just a moment to do a plug. If you notice, in linear motion, you start with a position function. The position function is often called S of t, sometimes called x of t if it's horizontal or y of t if it's vertical. But in general, usually we use S of t for position. I like to use P of t better than S of t because my S's tend to look like 5s. But anyway, whatever. Normally you're going to get an S of t, right? So your average velocity, that's the same thing as your average rate of change, right? Average velocity is the same thing as an average rate of change. Velocity is the rate of change in position. So if I have some position function, right? If this is my position and this is time, and I find the slope of this line at some spot, that's how fast I'm going, right? It's my rate of change of my position with respect to time. Okay, so that's why motion is such a nice application. It just works so well with calculus. So anyway, so average rate of change, which is normally displacement over time, how far have you moved, how long did it take you to do it, right? So it's typically f of a plus h minus f of a over h, or it's your f of b minus f of a over b minus a, right? It's the same, you guys know those, now you know those are interchangeable formulas. That's for average rate of change. Instantaneous rate of change. So now, say you want your instantaneous velocity. I want the velocity right now, like at this one spot, at this one point in time, how fast were you going? That's an instantaneous rate of change. That one is using the slope of the tangent formula. Slope of the secant, slope of the tangent. Average rate of change, instantaneous rate of change. Average velocity, instantaneous velocity. Okay, so we have time to do one good velocity problem. Once you guys are done, I think there's still some writing going on. Okay, we're gonna drop a ball from the top of the CN tower. Does it say CN or C? Isn't it CNN or is it just CN? CNN. I don't know. Anyway, we're gonna drop a ball from the top of this tower. Now there's a typo in this formula. This should be a negative right here. Okay, so the tower is 450 meters above the ground. We are dropping the ball from the top, the observation deck, using that, and that's our position function, negative 4.9 t squared plus 450. We want to know how fast the ball is traveling 5 seconds after we dropped it. So I want you to think about how tall that tower must be for that ball to still be falling 5 seconds after we dropped it, right? Okay. So how fast is the ball going when t equals 5? So for part A, so we want our instantaneous velocity, right? So we're looking for v at 5. V of 5. You have two different formulas for doing it. So you have your f of b minus f of a over b minus a, or your f of a plus h minus f of a over h. Which one do you want to use? Makes no difference to me. The a's and the b's?
Yeah.
Okay. Okay. So we would do the limit as t approaches 5 of v of t, s of t, sorry, s of t minus s of 5 over t minus 5. Do you all know your s of t function? This guy right here. Okay, that's your s of t function. You can do this without a calculator. Yes, you can. I hear all the calculators opening and like clicking around. All right, what's s of t? Minus s of 5 is negative 4.9 times 5 squared, which is, yes? You guys seem so nervous about 5 squared. 25 plus 450, right? Can you cancel something out right away? The 450s are gone, right? Okay, so we cancel out the 450s. And let's write what we have left. So we have negative 4.9 t squared plus 4.9 times 25 all over t minus 5. What would be a good thing to do here? Pull out the 4.9s, right? I would actually pull out a negative 4.9. I am not one to multiply first and then divide. If I can factor out and never have to multiply, that's what I do. So pull out that negative 4.9, and then life should, like, the solution should reveal itself. Luke, what's your favorite F word? It is. It's mine too. Yeah. So, and hey, what kind of a thing is that? This is your favorite. Difference of squares, right? Okay. I'm going to take a minute, factor, cancel, see what happens. What's negative 4.9 times 10? Negative 49. No we don't need no stinking calculators. Okay, so we've got negative 49. We need units. What was the position? What were these S's measured in? Meters. What was the time measured in? Seconds. So our units are meters per second. So units, meters per second. All right, that's part A. What? Now we're going to do part B. we're not going to do the whole thing, but I'm going to give you a little tip on it, okay? Okay. So part A said, how fast, what's the velocity of the ball at t equals 5? Part B says, how fast is the ball traveling? In other words, what's the velocity? When it hits, by the way, before I even go back to this, does it make sense that our velocity was negative? Yes, because it's going down. Okay, good. All right, you don't need that. Okay, so how fast is the ball traveling when it hits the ground? So, how do I know when it hits the ground?
Solve for 0.
Solve for 0.
Oh, you said set S to 0.
Set S to 0, not velocity to 0? Don't you stop when you hit the ground?
That's your position.
Okay, you're absolutely right. So, when you need to find out when something hits the ground, that's when your position is 0, right? When you're at the top of the building, your position is 450. At the ground, your position is 0, right? Your velocity is not 0 when you hit the ground. If you hit the ground, if you could jump off a building and hit the ground with a velocity of 0, we'd all be jumping off buildings, right? Because you just float down and stop and just keep on walking, right? Okay. So anyway, when you fall, right, you hit the ground with a velocity. That's what makes it dangerous, right? Okay. So now, a moment after you hit the ground, your velocity is 0, right? But at the moment, there's a velocity there. So don't set your velocity equal to 0 to find when you hit the ground. You set your position equal to 0 to find when you hit the ground. So for part B, and we don't have time to do the whole thing, but I'm going to just mention this. So to find out when we hit the ground, and then I'm going to give you a little pointer. So you have negative 4.9 t squared plus 450 equals 0. So t squared equals whatever 450 over 4.9 is. So you get t equals plus or minus, and I can tell you because I did it on my calculator earlier.
It's 9.58.
It's 9.58314845.
That's a
Okay,
calculator?
this is a calculator question. Yeah, that's a calculator. Okay. So, couple questions. Number 1, I have 2 times here. Which is the one I want to use?
Positive.
The positive, right? Okay. Because the negative would be 9 seconds before I threw the ball, which didn't make any sense. So we want to use the positive time. So we're talking about the positive time. Question number 2. On the AP exam, if you ever write an answer that's a decimal, it must be correct to how many places? 3. So if I round this number here to 3 places and then do a whole bunch of math with it, is my final answer still going to be correct to 3 places? No. You never round in the middle of a problem. So if you can't round in the middle of the problem and you have to sit here and do a limit and your A is 9.583148475, right? No one on earth wants to write 9.583148475 the 26 times you're going to have to write it to do the limit, right? So instead, here's what you can do. On quizzes, on tests, on the AP exam, the College Board does this all the time, right? You just say, hey, let A equal 9.583148475, and then when you're writing your limit, we can say, hey, we have the limit, I don't know which one you do, but h approaches 0 of f of a plus h, so s of a plus h, so it'd be negative 4.9 times a plus h squared plus 50 minus s of a, 4.9 negative 4.9 a squared plus 450 all over h. I'm using the second definition now, right? And now it's much easier math because you don't have all those big ugly decimals in there, right? Now when you have a negative 4.9 a squared and a positive 4.9 a squared, you're just gone, right? You don't have to worry about squaring out that big number because it's just called a, right? You get it all down to the end, and then when you're finally done, then you go back and plug in the A. Does that make sense? So much easier when you have to do a lot of work with decimals to just give them a letter name work with the letter, and then put the number in at the end if you have to. And by the way, your calculator, we'll get into this. We don't do a lot of calculator work the first couple of units. But if you have a lot of calculator work to do with a big long decimal, I'm going to teach you how to store it, right? You store it to letter A, and then every time you write the letter A on your calculator, you just hit the letter A, and it's putting in that number every time, right? So anyway, so fun with calculators. I'm going to ask quick mention. This formula should look just like this formula, right? Okay. The only difference is that instead of an A, which is a number, we have an X. If you keep XX instead of putting in a number for it, what you'll end up getting is some function at the end with an X in it. The nice thing about it, so if I actually did this where, like say my function was y equals x squared, if I actually do this, my final limit after all the work would be 2x. What does this give you? So this gives you slope, right? This gives you a slope for any value of x. So if you have a whole bunch of x's to plug in, you can do the slope without any numbers, just with a letter, and then say, hey, so if x is -1, my slope's -2. If x is 0, my slope is 0. If x is 3, my slope is 6. If x is 5, my slope is 10. Right? And just plug in all your slopes. Bam, 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 bam. Right? It's kind of nice. So it's kind of like your own little slope finding function. Right? So anyway, but that's for another day. We're going to get deeper into this kind of stuff over the next 2 days. We have 3 days to spend on slope. So if you were overwhelmed today, that's okay, because we got all day Monday and all day Tuesday. And then we are reviewing Wednesday, reviewing Thursday, reviewing Friday. Like there's 3 review days before you actually take your test. So